Hi again, back with the fourth of my, is it four or five of my, I guess it's number five of these patch a day. You can tell I'm going to get confused with these. Today I'm going to make something where I use audio analysis to drive comb filters to make sort of resonant pitches based on the input. I'm going to use SF Play for this thing, so I'm going to make a new patch with the SF Play object, and I'm going to want to open a file to play through this thing. So I'm going to make a message, open one of the sounds that comes installed with MaxMSP, the Cherokee.aif file. Put a comma there so I can type some more messages. Loop 1. The comma separates out messages into individual messages. I guess you probably know that. Another comma and a 1. So essentially what this message says is open Cherokee.aif. That's the first thing. That opens up the file. The next thing it does is give it the loop message with a 1 argument, so that's to turn the looping on. And then the last thing I do is to actually start the playback with the 1, with all of these commas separating out the separate parts of the message. Okay, I'm going to hook that up to the SF Play, and now I'm going to use an object to do the analysis, very similar to the first of these patch days. I'm going to use the Fiddle object, which you might not have installed again. If you want to find it, it's probably best to get out on the internet and Google Fiddle, and it's just spelt like the violin. Fiddle tilde and MaxMSP, and you'll again go back to the Miller Puckett's site where Ted Appel has ported the objects to MaxMSP. Assuming you have it installed, it might still not look like it's installed because it can come up with this message. The only object that I know of that does this when you don't put any arguments in it, Fiddle out of memory. That's because it needs some arguments. You can just open up the help file if we alt click on that Fiddle tilde, just to see what kind of arguments it likes. These are the arguments it takes. It's very small. The 1024 is the window size, 1 is the number of pitch tracking outlets that would come out here, that would create extra outlets. This is for the sinusoidal decomposition, very similar to the Sigmund thing that we looked at in the patch a day one. I'm going to just copy those arguments. That sounds good. All right, so we'll just use the arguments that help patch comes with. Since I'm not fussy, I don't need that patch anymore. And I'll connect my SF Play, and we're going to get out of this left-hand outlet here. Actually, we can even just have a look at what that is. If we create a float box and connect that up, you can see that when we're going to need some audio, so I'll get myself a easy DAC and turn it on and start the playback. And we'll see here some numbers coming out of the Fiddle tilde. These are MIDI numbers, so they're basically floating point MIDI values. That's very good. I can turn that off again. And I guess we're going to use, at the bottom end of this thing again, I'm going to make a new object for the comb filter. Comb tilde is what it's called. And again, to see what kind of arguments the comb filter likes. I'm just going to copy that. These arguments are the maximum size for the delay. This is the actual delay time. This is the gain coefficient. All right, and the feed forward and feedback, the actual feedback and the delay are probably the ones we're going to deal with today. So I'll just copy those, paste it in. And just for a start, we're going to want to make the feedback higher so that it's a bit more resonant. And we're also going to want to maybe, I don't know how low the frequencies are going to go. We might want to, it doesn't really matter how big this maximum delay time is. course, it could eat your CPU if you made it huge, but that's probably not going to be an issue for most comb filter usage. And we're just going to feed our SF play signal into there as well. That's to actually delay or create a comb filter on the SF play signal. And now we're going to want to change this delay time. We could hear what this sounds like actually if we just connect that up. Okay, if you're familiar with comb filters at all, you'll know that's the sound of the comb filter. And we're going to change the delay time here. One of the advantages to doing this, or one of the reasons I do this, is because in a live situation, the comb filters are notoriously bad for feeding back. So you create all sorts of feedback issues if you put comb filters in a patch for live performance with microphone input in particular. And by changing this delay time, you kind of kill the feedback, if nothing else. And so we're going to see here that this is a delay in milliseconds. So somehow we've got to translate this value, which is a MIDI note number, into a delay in milliseconds. The first thing that I would do to make that happen is to make a new object, and the M2F object that we've seen 1,000 times before. So we're turning the MIDI value into a frequency value. And the next thing is probably to get the reciprocal of that frequency, because we're going to want the period instead of the frequency. So to get the period in milliseconds, we would divide 1,000 by that frequency. This is the reciprocal divide by object, where the 1,000 divided by whatever comes into this left-hand inlet is generated by just this exclamation mark with the divide by symbol. So it's an exclamation mark divide by. I think we've seen that before too. All right, so this should be able to change the delay time, so that now this is going to change it. All right, very nice. And the other thing that I do quite often is to have a few of these in a bank. Well, we'll call it a bank, but let's just create 3 for now. Maybe I'll have a little bit of panning action. We'll have this one over at the far side, go into both left and right. And we'll make these, first of all, connecting them all to the SF play. And then using some kind of multiple of the frequency or division of the frequency. So we'll take this delay time here, make it longer for this comb filter in the shorter. Sorry, we'll make the delay time shorter for this comb filter, and then make it shorter still for the last comb filter. So we're getting basically a set of comb filters based on the harmonics of the input. Something like this. Alright, so that's that for today, and I'll check you on the next one.